Alright, in today's class, we'll be looking at how to write the electronic configuration of an element using the SPDF method. Alright, so let's look at how we can write the electronic configuration of an element using the SPDF method, and also let's see how we can also use them to identify the period and the group of an element. Am I communicating? So the first thing we're looking at is how to write the electronic configuration of an element using this particular SPDF method. Now look at this. We have what we call what? The SPDF. So just like under here, we have the one we call the S orbital, the P orbital, the D orbital, and also the F orbital. Now there's something I want you to take note of. Now look at the S orbital. Now I will make a table here. So these are the orbital, and this one represents the maximum number of what? Electron. Now look at this. So these are the orbital and their maximum number of what? Electron. Okay. We have the S orbital. Now for the S orbital, the maximum number of electron the S orbital can contain is 2. Now for the P orbital, the maximum number of electron the P orbital can contain is 6. The D orbital, the maximum number of electron the D orbital can contain is just 10. For the F orbital, the maximum number of electron the F orbital can contain is what? Is 14. So for the S orbital, maximum is 2, meaning that it can have 1 or 2. But the moment you reach 2, you have to get over to the next step, that is the next orbital. For P orbital is 6, so it can have 1, 2, 3, 4, 5. But the moment you reach 6, you have to choose the next energy level. So these are how they are being handled here. So because the first thing you are meant to take note of is what are the maximum number of electrons each of these orbitals can contain. So you can actually see them here. Now, while writing the electronic configuration of an element using the SPDF, there is something I called a map that you can actually follow in order to understand this. Okay, now look at this. Look at this. Look at the map here. We have the 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Now you draw your arrow. You draw your arrow. Now look at this. Look at this map. 1s, and we have 2s, 2p, 3s, 3p. Just look at this particular map. Whenever you are trying to write down the electronic configuration of an element using the SPDF, you must definitely make use of this particular map. Now, okay, now let me number them. This is 1, 2, 3, 4, 5, 6, and this one is the 7th one. So it's very, very simple. What does that mean? Whenever you are trying to write down the electronic configuration of an element, the first one you will choose is this first one. You can see this 1s. Do you understand? After filling the 1s, you will get over to the number 2 one. Look at that's why I numbered them. Look at the second one here. You pick the 2s. After filling the 2s, you will get to the next one, which is this next arrow, which is number 3. Now look at it here. You will first of all pick 2p. After filling 2p, you will now get over to 3x. The same thing. Then after, when you are through with them, you will now get to the 4th one. You will first of all fill the first one you are seeing, which is 3p. After filling 3p, that's when you can now think of filling 4s. When you are through with them, so it is actually a sequence that will help you to write down the electronic configuration of an element. Now look at this. For example, let's say that you want to write out the electronic configuration of a carbon using SPDF. Now remember, that at least you should be able to know the first 20 elements and also, know their atomic number. So let's say, for example, carbon. You ask yourself, what is the atomic number of carbon? The atomic number of carbon is what? 6, right? So let's write the electronic configuration of carbon using the SPDF. So this is carbon. So the atomic number of carbon is what? Is 6, right? Now look at the sequence now. Remember, I said that this is a map that you must know whenever you are trying to write the electronic configuration of an element by making use of the word SPDF. Now, so carbon has 6 electrons, right? Now what will you do? This is 1s.